Good morning, Discrete Math people. I would like to start today by complaining. I'm looking at the results here, and 15% of the people signed up in the English group haven't done anything. Not a single thing. So if you're one of those people who have done nothing, I really need you to consider right now, will you either do something today to actually get some points, or will you just contact the Department of Inscriptions and tell them that you will not be taking this class anymore? Because not doing anything is not a viable option. I understand there is no deadline here. I'm not forcing you to do all of the homework, but you choosing to do nothing at all is a guarantee that you will actually fail the class. So you're just wasting your time, my time, and everybody's time if you're not doing anything. The people who are doing pretty well here are the software engineering students. They have an 88% participation in the first homework. In second place, we have the systems engineers. And in the tail, we have the mechatronic engineers. So please, 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 if you're one of these people who have done nothing, either start working or give up. I will keep complaining about this every single week. If you have a friend who's signed up who's done nothing, tell them, "Wey, ponte a jalar o date de baja." We're not going to keep these people who do nothing around. We are not. We will be working among people who are actually studying discrete math. If you have no intention of actually studying discrete math, or you plan to do it some other time, please take the class some other time, not this time. Okay, so what we're doing today, if we look here in the schedule, today is the 19th of August. So we're going to have a regular class in which we're going to start homework number 2. We're going to be working on questions 1 and 2. So again, as a reminder, if you don't want to listen to explanations, we have videos. So for homework 2, the YouTube videos are divided by groups of questions. So the T2P1 video has the explanation for the questions 1 and 2 that are the ones we're going to be working on today. So that's the one that doesn't have any audio, so you can just slow it up or speed it up as you require. I would like to remind you to look at the example section. There's a lot of stuff in the example section that's relevant to what we're doing now. And I actually linked some of that stuff here above. I linked one about permutations, one about the power set, and one about the binomial coefficient. These are things that we need to be working today. Also, I still think you guys need the textbook, and there's full chapters and sections on pretty much everything we're looking at in the textbook. Also, the bot knows how to do a couple of things, a couple of the calculations we need today. I will soon explain what the factorial is, but the bot already knows how to calculate it. And I will soon explain what the binomial coefficient is, but the bot already knows how to calculate it. So we can use the bots also instead of Discord when we want to respond to tiny little questions like the 2 first questions of the homework today. Okay, remember to register when somebody helps you. If you're the one who's helping, ask the other people to do that. Remember, anytime you answer any homework, you need to check the result list. What I'm going to do today is I'm going to go to the homework system, the mobile system in English, and we're going to copy my questions from there. So I'm going to go to assignment 2, question 1. This is the very first thing that we are going to be doing today. Going to head on to the whiteboard so we can think about this on the whiteboard. So we're permuting the letters A to G, and then we're fixing C and G. Okay, first we need to find out what on earth is a permutation. So let's start with that. Okay, let's write here what we're supposed to be doing. A, B, C, D, E, F, and G. And the homework says First to appear is C. Last to appear is G. Okay, so let's work on the concept of permutation. If I have a set of objects, let's say I have this marker here, and I want another one that looks different so that the caps are different. I have these three markers here. They all look slightly different. So this is a set of markers, and while it's a set, it doesn't matter how I order them because sets don't have an order. But then if I want to order a set, I have different ways of doing it. I could put either the tallest marker on one side and then the shortest on the opposite. This is one ordering. Or I could flip it around. That would be a second different ordering. Or I could move the middle guy over here. That's a third ordering. Or I could move him over here. That's a fourth ordering. And then I could move those two around. So I can make several different orderings with these three items. So let's suppose that these items would be called X, Y, and Z. So that would be my first ordering for these three items. I could keep the X in front and turn the other two around. Or I could choose to put Y in first place and then have either X followed by Z or Z followed by X. Or I could choose to put the Z in the first place and then have either XY or YX. So now I have 6 different ways of ordering three items. The number of orderings for items is called the factorial. So the factorial of 3 is a 6. Because 6 objects, 3 objects give me 6 orderings. If I only had 2 objects, let's get rid of one of these markers. I have 2 objects, let's call them A and B. So the orders I could have is either A first and B second, or B first and A second. I have no other options. So the factorial of 2 will be 2. If I only have one single marker, I will only have one single ordering. So factorial of 1 will be 1. Now, let's figure out the factorial of 4 so that we can actually arrive at a formula of how to do this, because 1, 2, 6 gives ideas but doesn't give any kind of proof of what's going on. So let's say I have objects. Let's call them 1, 2, 3, and 4. If I had only the one object, my only ordering was the 1. If I have 2 objects, I can either add the 2 behind the 1 or in front of the 1. So the 1 factorial gives rise to 2 factorial because I have 2 different places where I can put this 2. Then when I get to the 3 factorial, I can put the 3 either here or here or here, or here or here or here. So it's going to be 3 times these guys and 3 times these guys. So it's 3 times as many. So I got this one from 1 to 2. It was 2 times 1. Then here it's 3 times this. So it's going to be 3 times 2 times 1. And the orderings that I'm going to get, this one here is going to give me 3, 1, 2 if I put the 3 here, 1, 3, 2 if I put the 3 here, and 1, 2, 3 if I put the 3 here. The bottom one will give me 3, 2, 1 if I put the 3 in front. It'll give me 3, 2, 1 if I put the 3 in the middle, and it will give me 2, 1, 3 if I put 3 in the end. So now for the 4 factorial, what is going to be going on? I can put the 4 here, 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 or here. And here, 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 or here. Here, 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 or here. So all of these 6 things will give me 4 new orderings. So this is going to be the 3 times the 3, 2 times the 1, but that thing's going to be multiplied by 4. And now remember, it doesn't matter how I order them. 1 times 2 is 2 times 1. This is the same as 1 times 2 times 3. This is the same as 3 times 4 times 2 times 1. So I could just always order them from 1 to the argument. 1 times 2 times 3 times 4. So now I could prove by induction that since whenever I have a fixed amount of elements here, let's say a k amount of elements, the amount of new positions where to insert an element will be either before, among, or after. So I will always get k plus 1 new places to put the new element. So I'm always going to be multiplying by k plus 1 when I add the k plus 1th element. So now we actually have a formula. I know that if I want the factorial of k, I will be multiplying all the numbers from 1 up to k. I could use the mathematical notation of an uppercase pi with an index that goes from 1 to k, and this would be the product of all the i's where I goes from 1 to k. So this would be the factorial. And this gives us how many permutations do I have for a fixed set of elements that I wish to reorder. Notice that they have to be distinct elements, because if they're not distinct, this idea here fails. If I'm putting duplicates of elements, then it doesn't matter if I have a BAA or a BAA where the A's are the other way around, because that's indistinguishable, whereas an ABA would be a different ordering. So what we're talking about here is orderings where all the elements are different, all the elements are distinct. So we have now derived a formula where the amount of permutations we will create is the factorial of the amount of elements we have. This is actually pretty easy to understand if we think about it as if we had blocks that we're trying to put in boxes. So suppose you have here a wooden block with the letter A. I have here a wooden block with the letter B and a wooden block with the letter C. Then I have this box. This box here has 3 slots on it. And I want to know how many different orderings can I use to make different combinations of letters in these 3 boxes. So I have 3 different options on what to put in the first slot. Once I filled the first slot, the remaining 2, either of them could go in the second slot. When both of those slots are filled, I only have 1 option to go in the last one. So that again gives me the factorial. So I can reason it either in which to pick to each position, or I can reason it recursively like I did before, thinking about where to insert the new element if I already have the permutations of a lesser number of elements. I'm not taking photos of this because this is really very elementary. It's in the textbook if you want to look at it. And also on the examples page, there's the factorial example. So now, how would I go about generating all the orderings? We can reason this with the recursive reasoning. So if let's say I would have to now make all the permutations for a set that contains A, B, C, D. We know it's going to be 4 factorial orderings. So that's going to be 6 times 4, which is 24. Since all these elements are equally important, I know that they will all take first position the same amount of time. They will all take second position the same amount of time. So if I have 4 options to make 24 arrangements, each of these needs to appear 6 times in the first position. So I'm going to have 6 orderings that are going to start with an A. I'm going to have another 6 orderings that are going to start with a B. I'm going to have 6 orderings that start with a D and C, and 6 that start with a D. Because 24 divided by 4 is a 6. So now if I've put the A, it means I am still trying to position the B, C, and D. The factorial of 3 is 6, which matches this exactly. So out of those 6, 1/3 will continue by B. 1/3 of a 6 is 2. So 2 continue with a B, 2 continue with a C, and 2 continue with a D. Here, I have the B, so I'm missing the A, C, and D. So it'll be A twice, C twice, and D twice. Here I am missing the A, the B, and the D. Here I am missing the A, the B, and the C, 1/3 each. Now, I've placed the A and the B. I'm only missing the C and the D. 2 factorial, 2. 2 possible orderings, either C first and D after, or D first and C after. Here I am missing B and D. So it's either BD or DB. Here I'm still lacking B and C. So it's either BC or CB. So here I have to use the same exact logic. I have B and A, I'm missing C and D. So it's going to be either CD or DC. Here I have BC, so I'm missing AD. So it's going to be AD, DA. Here it's AC or CA. Here it's BD or DB. Here it's AD or DA. Here it's AB or BA. Here I have a CB or a BC. Here I have an AC or a CA. And then I have an AB or ABA. So that way I can make all of the 24 permutations and I don't have to think about it a lot. Now, to make this absolutely horrible and to force you guys to participate, we are going to work with 5 elements. If I multiply 24 by 5, well, 24 times 5, I get 20 times 5, which is 100, and then a 5 times the 4, which is a 20. So if I add here an E, I'm going to end up with a 5 factorial, which is 120 different orderings, but they will still be absolutely trivial to do. Absolutely trivial. 1/5 of these 120 will start with A. So what's the 1/5? It's 24. So I know I have 24 that start with an A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I know that 1/4 of these, because these are 5 now, I put the A's. So the remaining 4 will divide this into 4 parts. So since I have 24 things, they're going to be length 6. So I'm going to have 6 times the B. Then I'm going to have 6 times the C. Then I'm going to have 6 times the D. And then I'm going to have 6 times the E. Then, with the same exact reasoning of the B's, I know I'm going to get 2 C's, 2 D's, and 2 E's. Where I have the 6 C's, it's going to be 2 B's, 2 D's, and 2 E's. Where I have A and D in the front, I'm going to have 2 B's, 2 C's, and 2 E's. I have A and E in the front, so I'm going to have B's, C's, and D's. Then when I already have the ABC, I just need the DE or the ED. When I have the ABD, I have the CE or the EC. ABE, I'm going to have CD or DC. ACB, I need DE or ED. ACD, I need BE or EB. ACE, I'm going to need BD or DB, etc. So now what I want you guys to do, I'm going to post a picture of what I just did now. And I would want you guys to complete the column. Also, I want to point out to Alejandro, you cannot edit the post if you want to do an MVP. The bot does not look at edited posts ever. So if you edit, it's never going to look at it. It only looks at original postings. It doesn't look at edits. So when you make a mistake trying to talk to the bot, just delete message and do it again. Okay, my photo is coming and I will give you guys a couple of minutes. I'll put the stream on break so that you guys complete that column. You can just write the bottom part, take a picture and post it on the channel. when at least 3 people have been able to complete what's going on here. And no, don't do all of the 120, just the ones that start with 8. We're not going to do the ones that start with B, C, D, E, unless you're like way more autistic than I am and you want to do all of them. But we're going to take a couple of minutes so that you guys can do this. Okay, so 14 people say they know how to do this, but it's a secret. Okay, there goes Luis Ivan. I've posted mine. So I did it until the DB. Yeah, I think you have them all. They're not in the same order as mine. I always put the remaining two options in alphabetical order so I don't get confused. But you put like CB before DB, before BC at the end, but they seem to be all there. Okay, I believe we have the idea. Okay, so now, how is this related to what I'm asking in the homework? So let's imagine the homework would have been ordering A, B, C, D, E in such a way that A is in first position. So now we would have filtered down out of the original 120. We now have these 24 in which A was in first position. So now let's say we want the ones where A is first and D is last. So now if I wanted to do it this way, I would start going down the list and check if D is last. Here it is. Here it is. Here as well. Here as well. Also here and also here. I could also filter this much easier because anything where D is second, I already know D is not going to be last. So I don't even have to look at those because I know it's not in the last position. Also, if I know that D is third, D is not going to be last. So if I know that D is third, I could also discard those. Also here, I know that D is third. Then if D is fourth, it's not going to be there either. D is fourth, D is fourth, 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 and fourth. So I ended up with just 6. And this is not a coincidence because if we guys really think about this, what's going on here? If I want to permute these 5, but I fix A in first position and I fix D in the last position, it means they're not permuting at all. They're fixed. There's always an A in the beginning and there's always a D in the end. They're not doing anything. I only have 3 boxes to fill, and I only have 3 letters to put in those boxes. So by saying that one thing needs to be first and one thing needs to be last, it means they're not permuting anymore. So the homework is a trick question. People who don't really think about what they're doing, they will look at their 7 elements. They will conclude 7 factorial is 5040. Then they will write a list of 5040 permutations. Then they will filter out the ones where C is first. When they filter out the ones where C is first, they will end up at 720 options because C wasn't permuting anymore. Then they will filter out the ones where G is last out of those 720, meaning G isn't permuting anymore either. So they will end up with only 5 things that are actually being permutated. So to answer your homework, you fix one letter, it drops the length by 1. So if you had 7, you now have 6. You fix the second letter, if you had 6, you now have 5. So if you start with 9, you end up with 7. If you start with 8, you end up with 6. If you start with 7, you end up with 5. If you start with 5, you end up with 3. So it's always going to be factorial of the cardinality of this set minus 2. So that's what we're going to do. And that's exactly what's happening in my homework. So this is a really trivial, easy question to answer. All we have to do is look at how many elements I have. I count 1, 2, 3, 4, 5, 6, 7. How many am I fixing? 1, 2. 7 minus 2 is 5. How much is factorial of 5? It's really easy actually to do in your head because it's just the 24 times the 5. But we could ask the bot or we could ask Python. Let's also ask Python and let's do how to do it. Let's see how to do it the stupid way in Python, like generating all of them. Okay, I'm going to open a Python If I want to use the factorial, I have to bring it from the math library, from math, import, factorial, and then I could compute the factorial of 5. Here in the study material, I'm going to do Control F to jump to where factorial is. This is the formula I showed you guys before. This is the reasoning. This is how to use the factorial. This would be making our own subroutine for calculating the factorial. And there's a thing here for how to get all the permutations. So when we used to do this in the classroom, I would often see students try to do it the silly way. They would bring the library to do the permutations. Then they would make their sets of letters. So we have A, B, C, D, E, F, G. And then we would want to permute those. So let's get all the permutations. It's going to be a list, or actually just iterate them. So let's do a for ordering in permutations of. I'm going to separate them to the letters. Then we could check if the first element is, what was it going to be? It was going to be C, I think. And the last element was going to be G. Then we could print the ordering. So what did I do here? I printed out of all the 5,040 possible permutations, only the ones that start with C and end with G. Let me show what I did here. And now remember, this is profoundly silly because it's just multiplying together 1, 2, 3, 4, 5, 6. No, actually, in this case, just 1, 2, 3, 4, 5, sorry. So now this is silly, but you can do this. And if you want to get the numerical answer, we could add a little bit of reasoning in here. I could do first a counter, set it to 0. Then I could do that same for ordering thing. And in the if, instead of printing, I could just increment the counter by 1. So that after I do everything, I could check how many times was the counter incremented. So I can count them this way. And it's not always dumb to do this. It kind of makes sense to do this if you want to verify your theoretical result. Oh yes, and factorial 20 is absolutely enormous. And the bot is using JavaScript. So the bot can't do cool stuff like Python can. Factorial the 20 is this big. Factorial of 45 is this big. And JavaScript tends to give up around the same time as C would with like number presentation precision, especially with integers. So it's going to start giving negatives and it just doesn't make any sense. So when you encounter a problem like this homework problem, first think really hard, what are you being asked? Reason with a smaller example. Don't try to work out all the permutations for 7 elements. That's a bad idea because there's over 5,000 of them. Reason with like 3 or 4 what's going on here. Once you've understood what's going on here, generalize the reasoning to the real number of elements you have. And if you feel like you need to verify it by checking all the permutations, rely on Python. Don't try to do it at hand. You don't want to go over 5,040 things to see which 120 fulfill the first condition. No, which 720 fulfill the first condition, and out of those, which 120 fulfill the second. That would be a bad idea. So that would be the first question. Let's make a poll. While you guys respond, I'm going to wipe the whiteboard a little more so that we can draw new things for the second question. Let's get a screenshot of the second question. So now we're about to enter this part here where we're discussing how many ways do we have for selecting subsets. I am recommending section 1.3 of the primary textbook and chapter 5 of the secondary textbook. We're going to work on the whiteboard first, then we're going to check our answer in Python, pretty much the same way that we were doing with this permutation stuff here. So let's head on to the whiteboard to look at this thing here. Number of subsets from 1, 2, 3, 4, 5, 6, 7, 8 that contain two elements but have an empty intersection, meaning that there's no common elements with 4. Okay. Let's open this large so I can see it from the whiteboard, and off I go. Okay. So what's a subset? When I have a set of objects, a subset is a selection of some or all of them, could also be none. So if I have here these markers, let's get markers that aren't all equal. If I have these markers here, these 4, I could either pick none of them, that's going to be one subset. I could pick all of them, that's another subset. I could pick every single one of them individually, that's 4 individual subsets. Or I could pick any 3. When I pick any 3, I exclude 1, so there's 4 ways to get any 3. Or I could get any pair, this one with this one, or this one with this one, or with this one, and this here, and this here, and this here. That's a little easier to draw. So let's draw for 4 elements in particular, how to get all of the subsets. So if I have a set A that contains lowercase a, b, c, d, well, I'm going to first make the set of all subsets. That's the power set. It's denoted by 2 elevated to the power of a. A here is a set. So this is not a power of 2 in the numeric sense. This is going to be a set that contains all the possible subsets of A. The smallest one I can make would be I take nothing, and that's the empty set. I'm going to write in a different color the comments. Take nothing. It means 0 elements. Or I could take A by itself, or B by itself. I'm so bad at putting the commas today. Or C by itself, or D by itself. Those are the pick 1. So I am taking 1 element. When I only chose nothing, I had 1 way of doing it. When I chose 1 element, I had 4 ways of doing it. Now, if I want to take 2 elements, I could take A with B, A with C, or A with D. Then I could take B with C, or B with D, or C with D. So there's going to be 6 ways to do this. So A with B, or A with C, or A with D, or B with C, or B with D, or C with D. So these are my pairs, 2 elements, 6 ways to do it. Then my triplets. My triplets are going to be skip 1. So if I skip the A, I keep B, C, D. If I skip the B, I keep A, C, D. If I skip the C, I keep A, B, D. If I skip the D, I keep A, B, C. So these are skip 1. How many elements do I have? I have 3 elements. How many ways do I have to do this? I have 4 ways to do this. The last option is I take everything, A, B, C, D, and then I close the set that contains sets. So that's all of it, meaning I have 4 elements and I have 1 way to do this. Okay, so how many subsets did I end up having? I ended up having 1 plus 4 plus 6 plus 4 plus 1. So that's a 5, and that's a 5, and that's a 6. The total I have here is 16. This marker isn't very good. Total 16. Now, here, A here had 4 elements. The cardinality of A is 4. The cardinality of its power set ended up being a 16. And it's not a coincidence. If I take 2 to the cardinality of A, that's 2 elevated to the 4th power, which is 16. And this will always apply. The number of elements you have, if you take that power of 2, you will know how many subsets you are going to have. And I am about to show you guys why. The clever people already know why, but it's always going to be a power of 2. Always. Let's reason it very briefly and very clearly. I'm not going to take a picture of this because it's much better drawn in the example section. You can just look at the example about the power set, conjunto potencia. So let's reason why it's always going to be a power of 2. So let's say I have a set of objects here, x, y, z. All the subsets I can make, I can represent them with true or false, with or without every single one of these items. So take nothing would be false, false, false. Take everything would be true, true, true. So I really just need all different possible combinations of zeros and ones to create all the possible subsets. So 0, 0, 1 would be take only Z, whereas pure zeros was empty set. So then 0, 1, 0 would be take only Y. 0, 1, 1 would be take Y with Z. Then 1, 0, 0 would be just take X. 1, 0, 1 would be take X with Z. 1, 1, 0 would be take X with Y. And the 1, 1, 1, which I've written really far away, will be take all 3. Now, why did I write them in this order here? Why didn't I write them X first by itself, Y by itself, Z by itself? Why did I write them in this order? What point am I trying to make? Somebody type me in one of the chats. Why did I write them in this order? What's the point of writing them like this? All of them are there. There's the nothing, there's the X, the Y, the Z, X with the Y, X with the Z, Y with the Z, and everybody. But why did I write them like this? What are they? Kirby is typing. Yes, they are binary numbers. So if I write the numbers from 0 to 7, I have a total of 8 different binary numbers. Each one of them has different bits, so each one of them is a different selection. So now if I had 16 bits, which would be 16 objects to choose from, then I could make the 2 to the power of 16 different subsets. And this is pretty cool. We're going to do this with Python in a little while after we have actually reasoned what the answer to the question is going to be, because I don't want to lose the less computationally oriented people straight up. But this is the reason why it's always a power of 2. So now let's learn an easy way to do this without a calculator. And then let's learn another easy way to do this for just one particular value. So let's suppose that I am interested in knowing how many subsets of a specific size do I have. And here I'm going to write how many objects do I have from how many things I'm selecting. Actually, let's do it the other way around. Let's put here the how many do I have. How many do I have? We're going to denote it by n. So I could have no elements, 1, 2, 3, 4, 5, 6, 7, 8. Let's go up to 8. And then how many do I want? How many to pick? We're going to denote that by k. And I could pick none, 1, 2, 3, 4, 5, 6, 7, or 8. Okay. If I have nothing, the only thing I can do is pick nothing, and there will be one way to pick nothing. There is no way to pick one or more objects if I have 0 objects. If I have only one object, I can either pick nothing or I can pick everything. And picking everything is all one single way. So picking nothing would be the empty set. Here it was just the empty set. Here I could pick either the empty set or the only element that I have. So it's one way to pick nothing and one way to pick everything, and the rest of this doesn't apply. If I have 2 elements, I'm going to have one way to pick nothing. Then I'm going to have 2 ways to pick one thing and one way to pick everything. So I'm going to have the empty set. I'm going to have only the A or only the B. These are the 2, or A and B both. So how do I create one row from the previous one? If I had nothing, I take either the nothing or I add the new element. If I have nothing, like the first column is always going to be nothing. Like one way to pick nothing, regardless how many elements I have. That's very easy. And for the second one, it's always going to be either nothing or add the new element by itself or the existing elements by themselves. So here there weren't any existing elements to pick one, so it was just add the new one. Then when I introduce the object B to make 2 objects, it's either this A or the new object B. And when I introduce an object C, it's going to be either the A and the B that were already there or the new object C. Then when I add a D, it's going to be one of these or the D. So the second column, it just goes 1, 2, 3, 4, 5, 6, 7, 8, because it's always the ones I had before and the new object. It's also easy to reason. If I have 8 total, I have 8 ways to pick one. So that should be really trivial. Also, picking everything will always have one way to do it. So with 3, there's going to be a 1 in the column 3. With 4, there's going to be 1 in the column 4. With 5, there's going to be a 1 there. 6, there's going to be a 1 here. 7, there's going to be a 1 here. 8, there's going to be a 1 here. And it's always going to be undefined after that 1. You cannot pick more elements than you have. Okay, more reasoning. How many ways do I have for excluding one element? When I exclude one element, it means I pick one of these to throw out. I'm skipping one of them. So the second to last element will always be how many elements I had. Because if I have 5, I can skip either one of the 5. If I have 4, I can skip either one of the 4. The next elements are interesting. So let's say I have 4 elements and I'm interested in selecting 2 of them. How many ways can I select 2 elements out of 4? Well, I could select the 2 of the previous 3, or I could select one of the previous 3 and add the new element to it. So here it says that on the row 3, I had 3 ways to pick one. I had the A and the B and the C, and I had 3 ways to pick 2. I had the A with the B, I had the A with the C, and I had the B with the C. So now if I have the new element, the 4th element, D, I could put the D here, I could put it here, or I could put it here. Or I could just take these as they are. And those are the only ways to pick 2 elements. So I'm going to have these 3 plus these 3. So this 3 here plus this 3 here, it gives me a 6 here. Now, if I'm at 5 and I want to pick 2 elements, what am I going to take? I'm going to take either one of these 6 because they already had 2 elements. Or I'm going to take the single ones from the 4 that were the A, the B, the C, and the D. And I'm going to introduce the new element E into them. So I'm going to add E here, or E here, or E here, or E here. So it's going to be these 4 plus these 6, they're going to give me a 10. How many ways to pick 3 elements if I have 5? Well, either I pick 2 from the previous row and I add the new element, or I take the triplets of the previous row. So 6 plus 4 is a 10. And this rule keeps going. Every number here is going to be the sum of the one above it and the one before that. So here it's going to be a 15 and a 20 and a 15. Here I'm going to have a 6 plus 15, so it's going to be a 21. Here I'm going to have a 35. Here I'm going to have a 35. Here I'm going to have a 21. 1 plus 8. No, I'm being stupid now. 7 plus 21, it's a 28. This one's going to be a 56. This one's going to be a 70, a 56, and a 28. And notice it's always going to be symmetrical. Like from the center to the sides, I have the same exact numbers because I have the same way of picking 2 elements than I have of skipping 2 elements. I'm just separating. If I have 9 objects, and I want to make them in the groups of 4 and 5, it really doesn't matter which ones the ones I skip and which ones are the ones I keep. There's the same amount of ways to separate them, regardless of which ones I am skipping. So what we have here done here, it's called a Pascal's triangle, as people already know in both chats. So this is very wonderful. Usually you don't have to write it in such a complicated way. I wrote it like this so that we could tabulate it with the n's and the k's. Also, if you ask for Pascal's triangle from the bot, it's going to give you a much prettier drawn thing. So the Pascal's triangle contains how many ways do I have for picking things. So let's first use the Pascal's triangle to answer our homework and then learn a better way to do this. So I have a number of subsets of A, and my set A here has 1, 2, 3, 4, 5, 6, 7, 8. So it's asking me number of subsets that contain 2 elements. So the cardinality of A is my n, and it's an 8. And I'm interested in subsets of type 2. So now let's ignore the rest of the question for now. Let's just be rush and try to solve this with n8 and k2. So if I want to use Pascal's triangle, I have to go all the way to the row 8. But it's easy and fast because it's just summing things. So now I start with a 1, that's for the 0. Then the 1, 1. Then 1, 2, 1, 1, 3, 3, 1, 1, 4, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. And then the row I want, 1, 8, 28. This is the, I'm going to change colors. This is the how to pick 0, this is the how to pick 1, and this is the how to pick 2. So our response would be, at this point, 28. But why isn't the answer 28? We have to read the rest of the question. I want to pick a subset that contains two elements but has an empty intersection with the set 4. What does this mean in regular people talk? It means don't use 4. So if I'm not supposed to use 4 ever, it means I shouldn't even consider it. Let's take the 4 away. And if I take the 4 away, it means I only have 7 objects to choose from. So I'm choosing 2 out of 7. So I should be in the previous row, and my correct response will be 21. So by staring at your Pascal's triangle, you can find the answer to the homework. Now I'm going to give you guys a little second. Please write a Pascal's triangle without looking mine. Like take an empty sheet of paper, try to write it down. It shouldn't be difficult. Remember, if you do it like a pyramid like this, every single number is going to be the sum of the two numbers right on top of it. Like this 35 is this one plus this one. This 20 is this one plus this one. This 10 is this one plus this one, and you have ones on the sides. Please do that and post a photo on Discord, at least a couple of people. Let's take a tiny little break. Okay, so I'm hoping everybody got the hang of it. Like, you don't have to do it to very large numbers. Like, if you've done like the first 6 or 7 rows, I have full faith that you know what you're doing. So now we're gonna figure out how to do this without having to do the entire triangle, like how to calculate a specific number in it. The name for the specific number in that triangle would be the binomial coefficient n over k. We have a formula for it, and I'm going to explain why that formula works. And this formula is also going to use the factorial that we were just talking about. So I have n objects and I wish to select k of them. Imagine I write all the possible orderings of my objects. Here are all the possible orderings. So I will have a total of n factorial possible orderings for my objects. Now, I wish to choose k of these objects. So what am I going to do? I'm going to split the list to 2 parts. These are the k that I want to keep. These are the rest n minus k that I want to throw out. How can I figure out how many unique selections of k objects do I have? If we turn to look at the list of permutations we had before, we will notice that the same exact selection will repeat. So for example, here in the beginning, let's say I have 3 objects that I have selected. I might have an ABC or a CBA or a BCA, etc., but they all refer to the same selection of A, B, and C. Because when I'm selecting a combination, the order doesn't matter anymore. So every single ordering here represents a selection, and every single selection is repeated many times because it appears in all the possible orderings. So how many possible ways do I have to order the k that I selected? I have k factorial possible orderings for those. But now, if I selected, let's say, ABC and discarded DE, I could have also selected the same ABC and discarded ED, and that's also the same exact selection. So I'm having duplicates of the kept ones, and I'm also having duplicates of the discarded ones, because all the tails also repeat in every single permutation. So I have k factorial repetitions for every single head. And every single head is combined with n minus k factorial repetitions of every single tail. So I need to normalize by their product to cancel out the repeated ones and to only be looking at those selections, regardless of in which ordering do these objects appear. So that's the reasoning behind the formula. I need to take all the orderings, cancel out the repeated beginnings, and cancel out the repeated endings to be able to distinguish separate selections of objects. If you ask the bot for the binomial coefficient, it's going to give you this drawing much more beautiful. So we're now going to learn how to make these calculations quickly without using a calculator, just by hand. So let's say somebody asked you for the binomial coefficient where you have 15 objects and you want 8 of them. And now you're overwhelmed because you don't want to do a 16-layer Pascal's triangle for the n's going from 0 to 15. You just don't want to, because we can see easily on Discord on what Hector did. For n equal to 9, it's already a bit painful. Imagine n equal 15, you just don't want to do it. So we're going to use the formula. So what do we have here? I have a 15 factorial, an 8 factorial, and then 15 minus 8 is 7. It's a 7 factorial. Okay, so now, what would stupid people do? Stupid people would start multiplying this number here up top. It's a huge multiplication, and you're never going to do it by hand. Then they would multiply this number here. It's a huge one too. And this one, it's a huge one too. Then they would multiply them together, and then they would start a division. This is a horrible idea. Smart people can't do this. Engineers have to be smart people. Never just start doing calculations. Always stop to think. These are multiplications. When you have multiplications, you can cancel out common factors. And that's exactly what we are going to do. Because up top, I have 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. You don't usually even have to write this. I'm just writing it now to illustrate a point. So I have all this stuff up there. And on the bottom, I have 8 factorial. What's 8 factorial? It's all this bullshit right here. So this 8 factorial cancels against all this stuff here. So here I have the 8 factorial and the 7 factorial. All this stuff canceled out against this thing here. So what I'm actually dealing with now, it's just 9 times 10 times 11 times 12 times 13 times, I skipped the 14, 14 times 15. And underneath, I have the 7 factorial. 1, 2, 3, 4, 5, 6, 7. I'm not done canceling. Don't start multiplying. Silly people start multiplying. Reasonable, intelligent people analyze. First of all, why did I cancel the 8 factorial? Because it's longer. If this one had been the longer one, I would have canceled the longer one. I want to cancel as much as I can. Now I want to cancel more. So I need to start matching things here. For example, I have here a 12. 12 is the same thing as 2 times 6. So we can get rid of the 12 if we get rid of the 2 and the 6 as well. We can also get rid of the 1 because the 1 doesn't mean anything. Notice that I have many ways to do a 12, so I could also use the 3 and a 4 if I wanted to. But I'm going to use the 2 and the 6 now to show you guys step by step one way to do this. So I'm going to get rid of those. What do I have left? Up I have a 9. A 9 is actually a 3 times 3. Then I have a 10, which is actually a 2 times 5. Then I have an 11, can't do much with that. I have a 13, can't do much with that. Then I have a 14, which is a 2 times 7. And then I have a 15, that's a 3 times 5. So that's my top after the cancellation. On the bottom remains a 3, a 4, a 5, and a 7. So what do I do next? Let's get rid of the 7 that's in here. Let's get rid of the 5 that's in here. Let's get rid of the 3 that's in here. Here I have a 4. I don't have a 4 on top, but I have a 2 and a 2. So as a 4 is a 2 times 2, I take 1, 2 out of here and 1, 2 out of here. So what do I have left? I have 3 times 3 times 5 times 11 times 13. This is so much more doable than we started with. Okay, let me make some space to it. Let's actually take a picture first so you guys don't get lost. It's a bit messy, and the lighting is horrible, but more or less, here goes nothing. So let's make space to do this calculation here. So what I actually want to do now is this. 3 times 3 times 5 times 11 times 13. And I'm still not going to use a calculator. So let's start with the hard part. 11 times 13 is the same as 10 times 13 plus an extra 13. This should be a plus sign. Okay, so 10 times 13 is 130 plus a 13, so I have 143. Okay, so now I have a 3 times 3 times 5 times 143. Great. What's 5 times 143? It's 10 times 143 divided by 2. So I have a 1,430. I'm dividing it by 2. So I have a 715. Great. So now I have a 3 times 3 times 715. 3 times 3 times 715. What's 3 times 715? Well, 3 times 15, it's going to be a 45. 3 times 7, it sounds a lot like a 21. So I'm probably going to have a 2,100 and then the 45. So I should have 2,145 from this first multiplication here. Then I want to multiply that by 3. If I take 3 times the 2,000, I'm actually going to get a 6,000. 3 times the 100, it's going to give me a 300. Then I'm going to get a 60, and then I'm going to get a 12. So it looks like I have a 6,372 would be my, I don't have a calculator, but I have to calculate this anyway. So let's ask what the bot thinks. I'm going to ask it to calculate the binomial coefficient of 15 over 8. Pretty damn close. I made a mistake somewhere. 6,435. Let's use Python to find my mistake. The exam's multiple choice. So if you make little mistakes, you're still going to get the right answer because there's not going to be two numbers that are really close by. Okay, so let's fix this by looking at where did we go wrong. First of all, if the cancellations are wrong, 3 times 3 times 5 times 11 times 13. Come on, Python. My keyboard hates me. This keyboard has so much cat hair in it, you wouldn't believe. And the cat hair is under the shift key, so it's really difficult to write the multiplications. Okay, so the cancellations are perfect. My multiplications have an error somewhere. Let's find the error in my multiplications. First of all, the 11 times the 13. 11 times 13, that's entirely correct. It's the 143. Then the 5 times that should also be correct. 715, that's also correct. Then I was multiplying that by a 3, and I got, that's where I went wrong. I got 2,100. Oh, I don't even know what I did there. Like, I'll show this to you guys. This is so bad. This is total brain fart. I was adding a 2,100 to a 45, and I somehow concluded it's 2,124. So that's exactly where we are wrong. So if I hadn't concluded that incorrectly, we would have the perfect response. So it was in the very easiest part of the entire calculation where I made a mistake. But that's the whole point when you're doing binomial coefficients by hand. Cancel everything you can before making any calculations. I have seen people sitting in the classroom responding to the exam, practically tears in their eyes, and I'm like, honey, what's wrong? I go look at their piece of paper and they are trying to calculate 21 factorial by hand because they haven't canceled anything. 21 factorial is this long. This is not something you want to do by hand. And if you're trying to do it with your normal calculator, it's just going to give you an error. It's simply not going to work. So remember, always cancel out. Now I'm going to give you guys a moment to answer your question. I'm thinking you should have gotten it from your Pascal triangle, but please try to also calculate the binomial coefficient by hand. I'll do the simple one for mine on the whiteboard. So on my problem, I had 8 objects. I discarded 1, and I wanted 2 of them. So I ended up with a 7 over 2. So that gives me a 7 factorial here, 2 factorial, and 5 factorial. The one I'm canceling out is the 5 factorial because it's longer. So the 1, 2, 3, 4, 5 cancels out. Up here, I only get the 6 and the 7. Here is a 2 factorial, 1 times 2. The 1 times it doesn't matter, so there's a 2. This 2 cancels out from the 6 because the 6 is a 2 times 3. So I get a 3 times 7, that's a 21, and that's my entire calculation. So it's much faster than doing the Pascal triangle when you only want one single number. Let me get you guys a picture of this. And please do it for your own homework. I am going to need everybody to be able to do this by the time we do the midterm exam. And no, you're not going to ask the bot. No, you're not going to check in Python. I need to see in the exam your handwriting on a sheet of paper of you doing this. If the number seems to appear from the anus of the Holy Spirit with no reasoning, then you are in trouble because you are cheating. There should be some writing to reason where this number comes from. Okay, so as I promised, we're going to look at how to do this stuff in Python as well. There are library routines for the binomial coefficient, but we can practice making our own since it's not in the standard library, so it's going to be pretty easy. So we could make a simple one. I'm going to call it binom1. It's going to take an n and a k, and it's going to return the factorial of n divided by the product of the factorial of k multiplying the factorial of n minus k. But now notice I'm making the computer do the stupid stuff. I'm not allowing it to cancel anything out. I'm forcing it to do all of the calculations. So now if I ask for this binom1 thing for stuff like, I can't even type, 12 over 3, I get a number. And also notice it's giving me decimals. It's always going to be an integer, but it's going to give me decimals because it's working with the division between very large numbers. If I wanted to make it smarter, like a little bit smarter, I could cancel out some of the stuff. I'm going to make a little bit smarter version, smart binom. This is going to be a tiny bit smart, not too much. So let's do. I'm going to call nk the n minus k. And then the bigger one's going to be the maximum between the k and the nk. And the smaller one is going to be the minimum between the k and the nk. Then I'm going to do the partial factorial up top. So the top is going to start from bigger plus 1. Then I'm going to iterate for top in range. That's going to go from bigger plus 2, including n. I'm going to multiply. Oh man, I already ruined it. I can't multiply by top because top is the name of my variable. Starting over. Def smart binom, okay. Then I'm just gonna go straight here. Bigger is n if n is larger than n, no, k. K, if k is larger than n minus k, else it is n minus k. Smaller is going to be k if k is smaller than n minus k, else it's going to be n minus k. It doesn't matter if they're both the same number. What did I do now? K if k is smaller than n minus k. Oh, did I just use a tabulator instead of spaces? Yeah, that's what I did. That one has a tabulator, and this the other one had spaces, so it got angry. Let's use a tabulator there too. Okay, so then the top, let's just put top equal to 1 first, and 4 multiplier in range bigger plus 1 all the way to n. I did it again. I keep messing up with tabs and spaces. Python is very specific with that. That's the top. Tab. I want to multiply top by the multiplier. So that should do the part on the top. That's the remaining factorial after I cancel the bigger one out. Then I should return this top just divided by the factorial of the smaller one. And I think I used spaces again because I'm retarded. Let's try again. Bigger, smaller, top, 4, multiply the stuff on the top, and return. So let's see if it works or if I broke it. So let's try the 7/3. Okay, that looks good. Binom 1 gives the same answer, which coincides with what the bot is doing. But now if I ask this one, very large numbers here, it's going to do very large calculations in between, whereas this one should do less calculations because it's not doing the whole multiplication up top. But what we do by hand is even smarter than that because we're canceling out parts of the division. Okay, so that way we can calculate the binomial coefficients. How could we go about generating all of these subsets? Let's look at that too. So we had already agreed that we could use the bits of a binary number to see which elements would belong to a set. I'm pretty sure I've written this code for you guys before, so let's go look at it in the example section. Okay, example section. Let's go all the way down to combinatoria. So here I have permutations, code in Python, binomial coefficient, Pascal's triangle, also in Python, the power set example that I linked before, generating all the subsets and how many subsets by cardinality. And this is the Python that I am referring to. So here in the GitHub, I have a code that's going to be using the bits. So I'm going to be checking if a certain bit is 1 to determine whether or not an element should be included in the set. So every single one that corresponds to a 1 bit will be included, and the candidates that correspond to 0 bits aren't included, and then we can return the selection. So the subroutine cuales takes an integer, it takes a set, and it returns the subset corresponding to the positions of the ordered set here that were 1 bits in the binary representation. I have another subroutine bits. It takes the integer, it converts it into a string of zeros and ones, and then it just pads zeros in front if the string was shorter than the desired length. And then I'm using it here with different sets. So we can briefly test that. If this sounds complicated to you, please don't lose any sleep. If you haven't taken programming classes, none of this will make a lot of sense. but I wanted to show it for people who are actually proficient with basic programming. So I could first take this here, a little routine. So what does this do? If I give it a number, like let's say 24, and I ask it to give me a 10-bit representation of bits, 24, I get this. If I ask for a 6-bit representation, I get this. So it just adds zeros in front if the bits of the number aren't enough to fill it. Why do I put the zeros in front? Because this iguales thing here, if I want to show the person which were the bits that were 1 to explain why this one picked certain items, I can use that subroutine to print them. So what does this one do here? Iguales, if I give it an ordering, like let's say A, B, C, and D, and then I give the number that I want to represent, like say 3. 3 means, sorry, what did I do now? I didn't close the B. So if I ask it to give me the number 3, remember 3 in binary is 1, 1. But since I have 4 elements, I'm thinking 0, 0, 1, 1. So give me 3 means give me the last 2. Give me 5 would mean give me the B and give me the D. Give me 7 would be give me B, C, D. Give me 8 would be just give me the A, because I'm picking now the ones that correspond to the ones in the binary representation. So what am I doing down here? I'm making 2 test sets. Wish I knew how to copy paste. And what am I doing here? For each test set, I'm going to check how many elements does it have. I'm going to pick a length that I want to represent the things in. And I already know how many bits am I going to need. It's going to be 2 to the power of how many elements I have. And then for every single one of those integers, I'm going to print out what the bits would be and what the selected sets are going to be. I'm going to copy this from the raw representation. Copy, paste. So now it goes over both of my example sets. The first set contained the letters A, B, C, D. Number 0 picks nothing. Number 9 picks A and D, for example. The second set had the numbers 1, 2, 3. So picking 5 is picking 1, 0, 1 is picking the first one and the third one. So that's what the code does. That's in that example. So we are now at the point we wanted to be for today. We should have all the necessary information to respond questions 1 and 2 of the second homework, meaning that if you go to the result page, you should be looking at least 4 points in the second column here. So this person here is a little ahead. This person's missing the second question. This person has both of them. Let's make a little poll. If you need any help or if you're running into any trouble, let us know. Remember that you can calculate the factorials by using the Discord bot if you want to. You can also calculate the binomial coefficients using the Discord bot if you want to. It's important to know what you're doing, practice with small numbers by hand, and compare with what the bot is doing. So I can see a lot of people are doing well here, but also a lot of people are still kind of in progress. We still have also people who haven't finished the first homework assignment. If you need help, please let us know. Remember that we have a YouTube video of the entire first homework, and that there's a video specifically for these 2 parts, first parts of the homework 2, if you need to look at those. For next week, what do we do next week? Just so that you guys know what you're going to be reading before next class. We are going to conclude question 2. So we're going to work with, no, homework 2. So we're going to work with question 3, 4, and 5. So in the study material, how far are we going to go? We are going to finish unit number 2. So we're going to do all the rest of combinatoria. So if you go here to combinatoria, this is the stuff you were supposed to look for today. For next week, please read this part about demonstrations. I kind of touched the topic of induction before. There are some useful theorems that you should know that they exist. When I took this class in Finland, we had to know all this stuff. If I try to put all this stuff in the exam here, people will hyperventilate. Question 3 will have to do with the Fibonacci sequence. So that's going to be relevant for next week. There's more information on partial sums and series, a lot of mathematical notation that would be good for you guys to know. Convolutions, pretty nice to know. Gray code is extremely interesting for a lot of people. And I just noticed I'm missing a parenthesis in rank here. Let's go fix it. Come on. A lot of time before, until after the last time I made corrections. Last time correction was in April, and now it's August. Did I just say April? I think it said February. Okay, so all of this stuff, you're going to be reading it too. You guys should be looking at all of these things in other classes, but I've included them here just in case you haven't. Also, you should already be familiar with stuff like relations and maps. Please read those just in case. Knowing what exactly is a function. We're going to be working a lot with stuff like logarithms in the for the midterm course. So please take a look at this as well. I'm going to teach you how to do those in your head. Things about rounding. We also need to know rounding rules for the midterm. You should have seen them before. You probably haven't. We're going to be talking about the greatest common divisor for the midterm. Some basic group theory. The software engineer people will need this when they do cryptography later on. It's just to get used to the notation. And then questions 4 and 5 of the second homework have to do with this topic. That's automata. So please read the part about the Turing machines. So we're going to be familiar with all of this notation. I will be explaining it all next week. We're going to be reading these little transition tables because we're going to be executing Turing machines. So next week, we're going to do the Fibonacci sequence, and we're going to work with the Turing machine to execute, to get an output for a specific input, and to compute the execution time of the Turing machine. If you want to get a head start, you can start looking at the video for the second part. For people on Twitch, I would like to answer. It's not only IT students. This semester we have a mixture. I have students from the software technology bachelor program, also from the system administration one, and the mechatronics one. They're all engineers, but they're all different kinds of engineers. And for the other question, we don't use Python on the exam. The exam is going to be multiple choice. Everybody's going to do all the calculations by hand or in your head. So you don't need to worry about libraries for that. This is for most of my students a first time with Python, and for some of them, it might even be the first time trying to write some kind of an automated program code. So it's very important for us here to have a conceptual understanding so that we know what things mean, we can do them by hand, and that we also know that you can do this with computational tools. And in later semesters, they should be in other classes getting deeper and deeper into the how to make better use of Python, how to do less things by hand. But in my belief, if you don't have a good conceptual understanding of what you're doing, you're just going to be like a monkey with a keyboard when you're trying to use something like a SciPy, like the SciPy. You just don't really know what you're doing and why. So here we're just trying to do conceptual things. Also, remember, if you're not entirely sure if you've understood things well, you can go to the exam system. Should be working in both languages now. You put in your data, you're going to want to practice. You get the exam generated. Mine's going to come out in Spanish. The freaking math jacks, let me get rid of the dollars. There we go. So I've already promised we're going to talk more about the rounding and logarithms. We're going to talk more about modulos. This is the stuff you should have learned in the first homework. We're going to talk about this when we're done with the second homework. This is related to what we did in the first homework, so is this. We're going to be talking about prime numbers. Fibonacci sequence has to do with what we're going to be doing next week. And the stuff we did today is related to these questions here. This is a factorial. This is a power set cardinality, like how many subsets does CGL have. So we should be really easily able to answer these three here. For example, this is a 7 factorial. We already know it's 5040. This is a 2 to the third power. That's an 8. And this is a 14 over a 5. Let's do it on the whiteboard. 14 over 5. I'm writing here 15. Come on, head. 14 over 5. So I have the 14 factorial, I have a 5 factorial, and I have a 9 factorial. 9 factorial is the one that cancels. So I stay with 10, 11, 12, 13, 14. And the factorial of 5, I have a 2, 3, 4, 5. Remember, the 1 doesn't count. Let's take the 3 and a 4 against the 12, and the 2 and the 5 against the 10. So I have an 11 times 13 times 14. And now we could estimate which one of these answers that we're looking at could be 11 times 13 times 14. So basically, this is going to be above 1,000, very clearly, because it's larger than 10 times 10 times 10. So it's definitely not going to be option B. Let me take you guys a screenshot of the options that we had so you can reason how to do this more error-proof. So it cannot be the 364. That's way too small. The 1001 also feels kind of too small because these are numbers that are clearly over 10, all of them. Whereas the 9,000 and some, that just feels like totally exaggerated. It can't be that one either. So it's going to have to be either 2002 or the 3003. And now we could try to figure out which one could it be. So these ones, we already talked about these ones before. We reasoned that 11 times 13, it was a 10 times 13 plus a 13. So we had agreed that it was 143. So now I have 143 and I have to multiply it by 14. Okay, so let's do it by parts. Let's first multiply it by 10. I get 1,430. Then I am missing this thing 4 times. That thing 4 times is that thing twice. So 1, 4, 3, if I just sum it with itself, I should have a 286. Then I take that 286, add it up with itself, I get a 2 here. I have here a 16 plus a 1, it's 17. So that sounds like a 300 and then some. So now I have 1,400 with a 300 and then some. It cannot possibly be 3003. I don't even have to calculate it. I already know it has to be the 2002. So you can cut your calculation short when you're in the exam because it's a multiple choice exam. And I want to see the parts you did calculate. You don't have to do the full calculation. I just need to know why do you know that the answer is the one you picked. If you're guessing, you will write, I'm guessing. And I keep forgetting how to use my own bot. Calculate the binomial of 14 over 5. It's 2002. So from what we did today, you should have these 3 points guaranteed. So now everybody should be able to answer those 3, plus the base conversion ones, plus the logic ones. So we should be getting a 10 if we present the exam today. And we're going to spend 3 weeks practicing all of these questions to make sure everybody understands this notation. Everybody understands logarithms. Everybody understands residues. Everybody understands, in particular, octal and hexadecimal numbers. Everybody knows how to get the greatest common divisors. Everybody understands precedence rules. Everybody understands binary arithmetic. And remember, if you want to practice the exam in English, for you guys, it should come automatically because you're signed up in English. If you're not signed up, if you're just using it like I am, you're going to pick practice. You're going to flip the language because the default language is Spanish. And then when you generate the exam, you should be getting an exam in English. And it just auto grades itself. So just pick the options you want. You have to pick the 20. If you don't pick 20, it's not going to let you grade. Just guess them. In some questions, especially in the final exam, there's going to be more than one correct answer. So it should be really easy to get a handful of points at this one. So that's everything I wanted to say today. Please help your friends. Please ask for help here on the channel. Use the MVP if somebody helps you. If you have any trouble with homework 1 or the first 2 questions of homework 2, can you please come to the voice channel so that I can help you? Si sientes que te haría mejor escuchar que yo explique todo esto en español, recuerda que a las 12 voy a reiniciar en español. Tú puedes o verlo en vivo o puedes ver la grabación posteriormente en Twitch o en YouTube. I'm going to stop the stream now. I'm going to give you guys the link to the Twitch one on Discord, and then I'm going to start the export to YouTube so you can look at it later there. And if you want to watch all of this again in Spanish, I will see you guys at noon. Take care.